Hi students, welcome to Sainiketan online classes. Yesterday we have completed nomenclature of amines, primary amines, secondary amines and tertiary amines. Now I am going to start structure. Structure of amines. Here amines nothing but these are the derivatives of ammonia. Then what is the structure of ammonia? If you take ammonia, NH3, this is the ammonia. On nitrogen atom, here lone pair of electrons are present. Then what is the shape of this one? Pyramidal structure. And what is the bond angle? 107 degrees. Because here actually this nitrogen atom is undergoes sp3 hybridization, but here due to the presence of lone pair of electrons, repulsions are created between lone pairs and bond pairs. Thus bonds come closer. Thus bond angle is less than 109 degrees 28 minutes. Okay. Similarly here if you take primary or secondary or tertiary amines, here primary amines are NH2. So in primary amines, in on nitrogen lone pair of electrons are available, and here this shape is pyramidal because this primary amine is derived from ammonia only. No, this hydrogen atom is replaced by alkyl group, then it has similar structure to ammonia, that is a pyramidal structure only. If you take a secondary amines, so it is also pyramidal structure because in ammonia 2 hydrogen atoms are replaced by 2 alkyl groups. Thus here on nitrogen 1 lone pair of electrons are available, and here bond angle is also less than 109 degrees 28 minutes. Similarly if you take tertiary amines, tertiary amines also have pyramidal structure only because here these primary and secondary and tertiary amines are derived from ammonia only. Here 3 hydrogens are replaced by 3 alkyl groups, then we get to tertiary amines. Okay, thus here these amines have similar structure to ammonia, that is pyramidal structure. And here due to the presence of lone pairs, these lone pairs are present on the nitrogen atom in each type of amines. Due to the presence of lone pair repulsions between lone pair of electrons and bond pair of electrons, here these bonds are clumps closer each other. Thus here bond angle is reduced. Here what is the general sp3 hybridized bond angle? 109 degrees 28 minutes. Normal bond angle, but here due to the presence of lone pair on the nitrogen, bond angle is reduced due to repulsions between this one and this one, or this one and this bond pair of electrons, and repulsions are present between lone pair of electrons and bond pair of electrons. For example, if you take trimethylamine, means nitrogen atom has 3 methyl groups. Okay, then here on nitrogen atom lone pair of electrons are present, and here angle between 2 bonds is 108 degrees only. It is less than the bond angle, that is 109 degrees 28 minutes. Okay, thus in all cases nitrogen atom undergoes sp3 hybridization and bond angle is reduced due to the presence of lone pair of electrons on the nitrogen atom. And what is the shape of that molecules, either primary or secondary or tertiary amines? Shape is pyramidal structure only. It is similar to structure of ammonia because these all are derived from ammonia only. Okay, it is about the structure of amines. Next topic is preparation methods. Preparation methods of amines. First method is from nitro hydrocarbons. This method also known as by the reduction of nitro compounds. In this method, these primary amines can be prepared by the reduction of nitro hydrocarbons. Means here, if you take nitro alkanes or nitro arenes, because here are either alkyl group or aryl group, which is undergo reduction in the presence of SnHCl or FeHCl or lithium aluminum hydride or any catalytic hydrogenation. Means in the presence of nickel or platinum or palladium, you can take any one. Okay, then here oxygens and hydrogens are combined together, removed as water, H2O. Here how many oxygens are there? 2 oxygens are there. Okay, then how many hydrogens are there? 4 hydrogens. But after removing 2 oxygens, here 2 hydrogens are attacked on nitrogen. Thus we get here amine. So thus total how many hydrogens are involved? Here 2 hydrogens, here 2 into 2, 4. 4 plus 2, 6. 6 means here you can write 3. 3 molecules of hydrogens are involved in this reaction. Okay. Here nitroalkanes or nitroarenes are undergo reduction in the presence of SnHCl or FeHCl or lithium aluminum hydride or nickel, platinum or palladium catalyst. We get amines. So addition of hydrogens is called as a reduction, or removal of oxygens is called as a reduction. Thus here these primary amines can be prepared by the reduction of nitro compounds. Example, you take CH3NO2. What is the name of this one? Nitromethane. Okay, substituent is nitro, and here CH3 is there, that is 1 carbon alkane is methane. Is undergoes reduction in the presence of SnHCl or lithium aluminum hydride. You can use any reducing agent. Okay, then here oxygens and hydrogens are combined together, removed as H2O, and after removing oxygens, here hydrogens are attacked on nitrogen. Thus we get CH3NH2. This is the methanamine. Thus we get primary amine from nitromethane. Second example, you can take any alkyl group instead of R, C2H5NO2. What is the name of this one? Nitro. How many carbons are there? 2 carbons. Hence alkane is ethane. So name of this molecule is nitroethane, which is undergoes a reduction in the presence of any reducing reagent like SnHCl or nickel or platinum or palladium. Then we get here C2H5NH2 plus water. Here oxygens, hydrogens are combined together, removed as water. Remaining 2 hydrogens are attacked on nitrogen. Thus we get ethyl amine or ethanamine. This is the ethanamine. Okay. Like that, you can take any alkyl group instead of R. Then we get corresponding amines. Not only alkyl groups, you can take aryl also. Example, C6H5NO2. So what is the name of this molecule? This is the nitro substance is there. If it is not there, means that is benzene. Thus name of this molecule is nitrobenzene, which is also undergoes reduction in the presence of reducing agents like SnHCl or FaHCl. Then here oxygens, hydrogens are combined together, removed as water. Then remaining two hydrogens are attacked on nitrogen. Thus we get here aniline. Thus nitrobenzene is undergoes reduction with the reducing agent SnHCl or FaHCl or lithium aluminum hydride to form which one here? Aniline. Thus by this method we can prepare the primary amines from nitroalkanes or nitrohydrocarbons by the reduction. Second method is from nitriles. Nitriles means cyanides or by the reduction of nitriles. Or cyanides. Here primary amines can be prepared by the reduction of nitriles with reducing agents. Nitriles, cyanides means here general representation is RCN. CN nothing but triple bond is present between carbon and nitrogen, which is undergoes here reduction in the presence of reducing agents like lithium, aluminum hydride or nickel catalyst or sodium amalgam NaHG in the presence of ethyl alcohol, ethanol. Here Et means ethyl group. Generally in reactions ethyl group can be represented by Et. Et means ethyl. Ethyl means it is C2H5OH. So in the presence of these reducing agents like lithium, aluminum hydride or nickel or sodium amalgam, in the presence of ethyl alcohol is the solvent. Then here first one bond will break down like this. Then we have two hydrogens now. Thus one hydrogen can attack on carbon, another hydrogen is can attack on nitrogen. Thus we get RCH. This hydrogen is added to this one, and out of 3 one broken. Then remaining are 2 bonds are there, and 2 nitrogen, 1 hydrogen is added, and thus we get amine, which is again undergoes reduction in the presence of same reducing agents. Okay. Then again here one more bond will break down, and one hydrogen is added to this side, another hydrogen is added to that side. Thus we get here R CH2 NH2. So this is the primary amine. Thus here we can prepare the primary amines from nitriles or cyanides by the reduction. Reduction nothing but addition of hydrogens only in the presence of any catalyst like lithium aluminum hydride or nickel or sodium amalgam also acts as a reducing agent in ethyl alcohol. First one more here bond breakdown and hydrogens are added to both sides, carbon and nitrogen. Thus we get amine. This one is amine, which is undergoes further reduction. Again here one more bond breakdown. Thus we get finally primary amines. Example, R means you can take any alkyl group. CH3, C triple bond N. Which undergoes here reduction in the presence of any reducing catalyst. Then here one bond will break down. Then hydrogens are added to one this side. Thus we get here CH3 CH double bond NH. Again which undergoes reduction in the presence of same reducing agent. Then here one more bond will break down H this side H. Thus we get primary amine. So this is the ethyl amine or ethanamine. Okay, thus it involves in two steps. Otherwise you can write it directly also in a single step. If you want a general equation, then in a single step you can write like this also. Two hydrogens you can take at a time. Nickel catalyst. Then at a time you can break down. Here after breaking one bond, one hydrogen this side, another hydrogen this side. One more you can break down. This side one hydrogen, this side another hydrogen. Then directly we can get the primary amines like this. This is the primary amine. Okay. Similarly, this also can write it directly. CH3 C triple bond N, which is undergoes reduction in the presence of any catalyst, reducing catalyst. Then this side will break down bond. Hydrogens are added in same pattern like this. Thus we get CH3 CH2 NH2. This only ethanamine. Ethanamine. Okay. This here you can take another alkyl group C2H5 C triple N, which undergoes reduction in the presence of catalyst nickel. Then what happen here? This bond will break down. Thus hydrogens are added on carbon and one more is on nitrogen. After breaking this bond also, here hydrogen is added, nitrogen also get one. Thus we get C2H5 CH2. Next here single bond NH2. Thus we get primary amine. Thus what is the name of this one? It is a propyl amine. Propyl amine or propane 1 amine. Okay. Thus by this method we can prepare the primary amines by the reduction of nitriles. Nitriles nothing but cyanides. Okay, in the presence of any reducing agent. Okay. Next method is from amides. We can prepare the amines by the reduction of amides. Take first amides. Amides means here general representation is RCONH2, which are undergo reduction in the presence of lithium aluminum hydride followed by hydrolysis. Then here this bond will break down, this bond and this bond also. Then here two hydrogens, one oxygen removed as water, and here two more hydrogens are involved. Total 4 are involved. 2 hydrogens, 1 oxygen, H2 is removed. Then 2 more hydrogens are there now. These 2 hydrogens are attacked on this carbon. Thus we get RCH2 ENH2. So this is the primary amine. Example: Take any alkyl group instead of R. CH3, C double bond O, NH2. Acetamide, which is undergoes reduction in the presence of lithium aluminum hydride followed by hydrolysis. Then what happened here? These bonds will break down, no? Okay. Then actually what is happening, if you take one hydrogen, then after breaking here bond, one H is added to oxygen, one more is added to here carbon. One molecule is completed. Then we get in this case CH3 CH, here OH, next NH2. Okay. If you add one H2 molecule, after that again one more H2 is added to this one, then this bond will break down, here H is added, here one more H is added. Thus it can completely removed, and here we get CH2. Okay, thus it is also involves two steps, but you can write in a single step only. Okay, thus after adding two H2 molecules, two bonds will break down, and here this oxygen and two hydrogens removed as H2, remaining two hydrogens are added to carbon atom. Thus we get directly here CH3 CH2 NH2. This is the ethanamine. Okay. Can write directly, no need to write these all steps. Thus here acetamide is undergoes reduction in the presence of lithium aluminum hydride followed by hydrolysis. We get ethanamine. Another example, C2H5 C double bond O NH2. Propanamide undergoes reduction in the presence of lithium aluminum hydride followed by hydrolysis. Then what happened here? So here bonds break down, and two hydrogens, one oxygen removed as H2O, remaining two hydrogens are attacked on carbon. Thus here we get C2H5 CH2 NH2. So it is the propylamine. Okay. You can take aryl group instead of R. This is the benzamide, which is undergoes reduction in the presence of lithium aluminum hydride followed by hydrolysis. Then what happened? Bonds are break down, then two hydrogens, one oxygen removed as H2O, remaining two hydrogens are there, these are attacked on this carbon. Thus here we get CH2 NH2. This is the benzyl amine. Okay. Thus here these amines can be prepared by the reduction of amides. Okay. Thus it is the preparation method from amides. These amides are undergo reduction. Reduction nothing but addition of hydrogens, removal of oxygen in the presence of reducing agent, that is lithium aluminum hydride. Then we get amines. Next one is Hoffman bromide degradation. Important one. Hoffman bromide degradation, or it is also known as Hoffman bromide reaction. or simply Hoffman degradation or Hoffman rearrangement. Reaction. Important one. This method is used for conversion of amides into amines with bromine in the presence of alkali solution. Means you can take amides RCONH2 amide, which is react with bromine in the presence of sodium hydroxide or potassium hydroxide. You can take any one. Then here this CO is removed, then this alkyl group and NH2 directly can attack each other. So it can be directly attacked on alkyl group. Thus rearrangement takes place, RNH2. And here sodium and Br combined together, then we get NaBr, and here sodium and this carbon and oxygen removed as sodium carbonate, that is Na2CO3, and here hydrogens and OH are combined together, removed as H2O. Thus here how many bromines are there? 2 are there. Then you can write here 2. 2 plus 2, 4 sodiums are there. Then you can write here 4. Then how many hydrogens are there? Here 2 plus 4, 6. Here 2 plus here 2 only is there. Then you can write here 2. 2 into 2, 4 plus 2, 6. Here 4 plus 2, 6. Then oxygens 4 plus 1, 5. Here 3 are there, plus 2, 5. So here we get primary amine. Amide is react with bromine in the presence of alkali solution like NaOH or KOH also, to form primary amine by the removal of NaBr, Na2CO3, sodium carbonate and water. This reaction is called as Hoffman bromide degradation or Hoffman bromide reaction or Hoffman rearrangement reaction or simply Hoffman degradation reaction. Okay. If you use here KOH, then what is the general equation? RCONH2. This is amide, which is react with bromine in the presence of potassium hydroxide. Then here also this NH2 group is directly attacked on alkyl group. Thus we get RNH2, that is primary amine, and potassium and Br combined together, removed as KBr and potassium carbonate and water. Similar reaction only, but instead of this Na we have taken potassium. In products also, instead of Na we get K potassium. Here also instead of sodium we get potassium. Okay, remaining as it is, here 2, here 2. Okay, both you can use this one or this one. Okay, this reaction is called as Hoffman bromide degradation reaction. Amides are react with bromine in the presence of alkali solution like KOH, potassium hydroxide, or NaOH, sodium hydroxide. Then we get primary amine by the removal of here NaBr or KBr, Na2CO3 or K2CO3 and water. Okay, simply you can write definition. Amides are react with bromine in the presence of alkali like potassium hydroxide or sodium hydroxide to form primary amines. This reaction is called as Hoffman bromide degradation reaction. Examples. So instead of this R, you can take any alkyl group, CH3CONH2. This is the acetamide. is react with bromine in the presence of potassium hydroxide, then we get CH3NH2. This is the methanamine, and we get KBr, potassium bromide, potassium carbonate, and water. Here amide is converted into primary amine. This is the primary amine. Okay. Another example, C2H5 CONH2, which is react with bromine in the presence of potassium hydroxide. Otherwise you can take sodium hydroxide, your wish, any one. For example, if you take NaOH, then we get which one? C2H5 NH2, sodium bromide, and sodium carbonate, and water. This is the ethanamine. This is the propamide. And instead of that one, you can take aryl group also. Instead of R, you can take aryl group, that is C6H5 CONH2. This is the benzamide. Which is react with bromine in the presence of sodium hydroxide. Then we get aniline C6H5NH2 with removal of sodium bromide, sodium carbonate, and water. So aniline is also primary amine. Thus this reaction is called as Amine bromide degradation. Here benzamide C6H5CONH2 react with bromine in the presence of alkali NaOH. Then here CO is removed, this NH2 group is directly attached to this benzene, thus we get aniline. And NaBr and Na2CO3, and here H is removed and combined with OH, thus we get water also. Later again one more H is attacked on this one, thus finally we get here NH2. Okay. So here what you observed in this equation, for example, take first example, CH3CONH2 is there, estimate. How many carbons are there? 2 carbons are there. But in a product, how many carbons are there? Only one is there. Means product amine has 1 carbon less than the parent amide. Okay. Here also how many carbons are there? 2 plus 1, 3 are there. Here how many carbons are there? Only 2. Means amine has 1 carbon less than the amide. Here also how many carbons in benzene nucleus? 6. Here 1, 7. But in the product aniline 6 only is there. But here 6 plus 1, 7 are there. But here 6 only there. Means this aniline has 1 carbon less than that parent amide. Okay. Thus here note, in this method amine has 1 carbon less than the parent amide. If parent amide has n carbons, then amine has how many carbons? N minus 1 carbons. Okay. Parent has n number of carbons are present, then in amine how many are there? N minus 1 carbons are present. Because here CO is removed, no? Thus 1 carbon is eliminated. Remember that point. So indirectly they will ask in competitive examinations especially. Okay, they will give one amide, then get amine by the following of which method, like that they will ask. Okay, anyhow here amines These are obtained in this method has one carbon less than the parent amide. Is it clear?